In our discussion of relational logic thus far, we've assumed that there is a one-to-one relationship between ground terms in our language and objects in the application area we are trying to describe. For example, we've been assuming a unique name for each person. In arithmetic, we've been assuming a unique term for each number. This is often called an isomorphic representation because of the one-to-one relationship between ground terms and objects in the world. This approach makes things conceptually simple, and it's a reasonable way to go in many circumstances. But not always. In natural language, for example, we often find it convenient to use more than one term to refer to the same real-world object. For example, we sometimes have multiple names for the same person, Michael and Mike. And in elementary arithmetic, we frequently use different terms to refer to the same number. 2 plus 2, 2 times 2, s of s of s of s of 0, and so forth. In relational logic, we can axiomatize this coreferentiality of terms in the form of equations. An equation is our way of stating that two possibly distinct terms refer to the same real-world object. For example, to express the coreferentiality of f of a and f of b, we write equal f of a, f of b. We can also distinguish terms by writing negated equations. To say that two terms refer to different objects, we write not equal f of a, f of b, for example. Since equality is such a common relation, in what follows we'll write equations with the infix operator equal sign. For example, writing f of a equals f of b in place of equal f of a, f of b. However, this is just syntactic sugar. We must remember that as far as our logic is concerned, syntactically and semantically, an equation is just a relational sentence involving a relation constant like any other. We start this lesson by axiomatizing the equal relation as an ordinary binary relation. We then discuss the substitution of equals for equals in other expressions. And finally, we talk about how to expand our proof system for reasoning about equality.